Hi guys, good morning. Today we're going to continue with chemical bonds because some of you texted me that it wasn't very clear yet. So we're going to go back to the different chemical bonds. We just saw ionic bonds, all right, before Easter week. We started with ionic bonds. We haven't seen covalent bonds, but we're going to see it this week. So to start the class first, you need your books. We're in chapter 6, section 1. And 2, you need your periodic tables. If you didn't buy the periodic table, you can just print one you find on internet, but you need one. Without a periodic table, we're not going to be able to work. There is a periodic table on the book, but you need a periodic table that has the charges. And the one that's on the book does not have the charges, so you need to print one or tell Natalia or Angie, I think they have a periodic table, to take a picture and to send it to you, because we're going to be working with this. Alright, so an ionic bond, to start, it's a force that is going to attract 2 elements together. But what elements? Ionic means that you're going to have a metal plus a non-metal. Alright, this is an ionic bond, metal and a non-metal, alright? Covalent bond, on the other hand, is a non-metal with another non-metal, okay? But ionic bond, metal and non-metal. Which are my metals? You go to your periodic table, everything that's from this side to here, it's metals. And only this part, it's the non-metals. So that's why you need a periodic table. We also need to identify. So I told you, when we're going to make chemical bonds and we're going to start making compounds, we first need to look for the charges. And I'm going to start with barium. Barium is in group 2A, almost at the end. And because it's in group 2A, it has a charge of positive 2. Alright, and let's say I want to combine barium with phosphorus. Phosphorus is a non-metal, that's why I'm putting it in red. And phosphorus has a charge of negative 3. In order for us to make a chemical compound, we need to make those numbers on the top add up to 0. But positive 2 minus 3 is negative 1, so we can't do that. So we need to change those numbers, and an easy way of making it is just to exchange the numbers. So I put a 3 here, and I put a 2 here. Why? Because here I have a 2 and I put a 2 here, and here I have a 3, I put a 3 here. So 3 times 2, positive 6. 2 times negative 3, negative 6. And this adds up to 0. So my chemical compound is Ba3, P2. Alright? That is how we make a chemical compound. We need to make sure of our charges. Okay? So far we learned only with group 1 and 2 because they have charges of +1 and +2. But today we're also going to make with transition metals. Transition metals have different charges. So we're going to be using, if I don't specify the charge, we're going to use all of them. We're going to make the compounds with all of them. And if I do specify the charge, we're just going to make it with that charge. If you have no idea of what I'm talking about, please tell Natalia to send her a picture of the periodic table she has, because the one she has all of the charges. Alright, let's make another example. I'm going to grab an element from group 1A. Let's grab cesium. Since cesium is in group 1A, what charge is it going to have? Positive 1. So cesium has a charge of positive 1. Now let's grab a non-metal. Let's grab sulfur as a non-metal. Sulfur is in group, let me see, 1, 2, 3, 4, 5, 6A. Sulfur is in group 6A. And because it's in group 6A, it has a charge of negative 2. Remember that for me to make a chemical compound, I need to add this to 0. Positive 1 minus 2 is negative 1, so I can't do it. So I'm going to exchange the numbers. The 2 goes here, and the 1 goes here. But when I have a number 1, I do not represent it, so I don't put a 1. All right, so 2 times 1, positive 2. Minus 2 equal to 0. So my chemical compound in this case is cesium-2 sulfur. And that's my chemical compound, and that's it. Ionic bonding because I have a metal and a non-metal. All right, we're good? All right, so let's move an example with a transition metal. In a transition metal, which ones are the transition metals? The ones that are on the middle. Why are they called transition? Because their characteristics can change, so they're called transition because they change, they don't have a specific charges. So let's grab nickel. Nickel's, sorry, this marker doesn't work well. Nickel has number 28. If you want to look for it, it's number 28. And if you see the charges, nickel can have a charge of positive 2, and nickel can also have a charge of positive 3. All right, this is what I'm referring with transition metals. They do not have a specific charge, and if I don't tell you use positive 3, you're going to use both of them to make different compounds. All right, so we have nickel, positive 2, and nickel, positive 3. And we're going to add to nickel, we're going to grab oxygen. We're going to add oxygen. Oxygen is in group 6A. So oxygen has a charge of negative 2. Oxygen charge of negative 2. All right, so in the very first example, we have nickel, positive 2, and oxygen, negative 2. Positive 2 minus 2 is 0. So in this case, I don't have to change anything. It's already made. So I just copy my compound, which is going to be nickel and oxygen. All right. But then when I have nickel with a positive 3, I have positive 3 minus 2. It's equal to positive 1. So here I do have to make changes. So I'm going to exchange the numbers. All right, this one here and this one here. So because oxygen has a 2, I'm going to put a 2 to nickel. And because nickel has a 3, I'm going to put a 3 to oxygen. 2 times 3, positive 6. All right? 3 times negative 2, negative 6. Positive 6 minus 6 is equal to 0. So my chemical compound is nickel 2, oxygen 3. Are you getting this? This is really easy if you already learned how to look for your charges. So it's really simple. All you need is to have your periodic table that has the charges, all right? I'm going to make one last example. I'm going to put you a few examples that you need to make with transition metals. We're going to work with transition metals today. All right, let's grab, let me see. We're going to grab copper. Or better yet, we're going to grab vanadium. Vanadium. Vanadium is number 23. And vanadium can have a charge of positive 2. Vanadium can have a charge of positive 3. Vanadium can also have a charge of positive 4. And it can also have a charge of positive 5. But because of the space, I'm just going to do it with the 3. All right. Vanadium, because it's in here, it's a transition metal. So it's a metal. And I'm going to add it with chlorine. All right. Chlorine has a charge of negative 1. All right. Chlorine negative 1 and chlorine negative 1. Okay, so positive 2 minus 1, I have a positive 2. So I need to add it up to 0. So I exchange the numbers. The 2 goes here and the 1 goes here. But since we have a 1, the 1 is not represented, so you do not put it. So I just put a 2 here. 2 times 1, negative 2. Positive 2 minus 2, 0. So my chemical compound is vanadium, chlorine, 2. All right? And same goes here. Positive 3 minus 1 equals to positive 2. I exchange my numbers. I put a 3 here. 3 times negative 1 is negative 3. Positive 3 minus 3 is equal to 0. So my chemical compound is vanadium, chlorine, 3. All right? And the last example, positive 4 minus 1, it's equal to positive 3. So I need to make it up to 0, and I put a 4 here. And we have vanadium, chlorine, and 4. All right? And well, that's it with the transition metals and metals. I'm gonna make you one more example because there's something I forgot to explain to you. I'm gonna explain right now. But you see, it's simple as that. It's really easy, guys. All right, let me see. I'm gonna grab an example. 4. Manganese. I'm gonna use manganese. Manganese, and I'm going to use the charge of 4. If you're wondering where manganese is, it's number 25. And to manganese, manganese is a transition metal. I'm going to add oxygen. All right. Manganese is positive 4. Positive 4 minus 2 is positive 2. So in here, we can either do it in 2 ways. We were talking about exchanging the numbers, so I can put a 2 here, and then the 4 I can put it here. All right. 2 times 4 is positive 8, 4 times negative 2 is negative 8, and it's going to add me to 0. So my chemical compound is going to be Mn2O4. Chemistry kind of works like math. So if I have a 2 and a 4, I can simplify this formula, dividing everything by 2. So I divide everything in 2, all right? And my chemical compound is going to be MnO2. I don't know if you got this, all right, but I have this Mn, positive 4, and oxygen, negative 2, and I need to add it to 0. What number can I put to oxygen so that it makes me a 4? I can just put a 2, right? So I have positive 4 minus 4 is equal to 0, so my chemical compound is MnO2. If you do it this way, it's okay, it's good, but you need to simplify it later. All right, so this is making chemical bonds. I really hope you understand. Well, if you don't, please text me and I'm gonna explain it to you again. All right, I'm gonna upload the picture of the exercises you need to make.